Hi guys, in this video what we're going to do is look at what's called the modulus of a complex number. So I'm going to explain it on the diagram here and roughly what's going on, and I'm going to show you just with some examples which you'll probably find a bit easier. So at the moment we're quite happy that every complex number has a real part and an imaginary part. So for example, if I had a plus bi, where a and b can be any numbers, you can see 2 plus 3i, we can put it on an Argand diagram. We've already done this. Now hopefully you'll notice that what we have here is a right angled triangle. So what we're trying to do is we're trying to find the distance from 0, 0, or the origin here, to wherever we're plotting these complex numbers. So it's just Pythagoras is what we're using here, guys. Okay, so it says here the modulus is the distance from the origin, which is this from here to here. We can use the Theorem of Pythagoras. And if z is equal to some real number plus some imaginary number, then the modulus of z, and the modulus of z is given by these two straight lines, guys, is equal to the modulus of a plus bi again in these vertical lines. And that's equal to a squared plus b squared square rooted. Now, how do we do that? It's very, very straightforward. So if I told you that z is equal to 3 plus 4i, and I want to find the modulus of z, well, if you think about it, if I just label it, this here is z is equal to a plus bi, and we're told that the modulus of z is given by, so the modulus of z is given by a squared plus b squared square rooted. So all we do is just follow the rule. So you can see here, for the first one, my a is equal to 3. So this is equal to 3 squared. My b is equal to 4. I don't worry about the I, it's just what's in front of the I. So that's the 4, so that becomes plus 4 squared. And the rule says, look, take the square root of that at the end. So let's do that. Work it out. So modulus of z is equal to 3 squared, which is 9, plus 4 squared, which is 16. Square root the answer. 9 plus 16 is 25. Square root that answer. And if we do that, we get the modulus of z is equal to 5. So all we're saying is that if this was 3, this was 4, then by Pythagoras, all we've done is we've worked out this distance from here to here, and we've worked it out to be 5. And guys, that is finding the modulus. It doesn't matter what those numbers are in front of a and the b, whatever those numbers are, you just stick them into the formula. I'll just do another example with you. So before I go on to the next page. So let's say that z is equal to, let's go for minus 2 plus 3i this time. To work out the modulus, you can label it a, b, and we know it's a squared plus b squared square rooted, so the modulus of z is equal to, and we have a, which is minus 2 all squared, plus b, which is 3 squared square rooted. We know that minus 2 squared, minus times a minus gives us a plus. We'll never get a negative value when we square it, guys. This will always be positive. We end up with 4 plus 9 square rooted. And then if we add them together, we get 13, root 13. We don't know the answer to root 13, so we can just leave it as root 13. We can simplify this one because we know that root 25 is 5, but this is just root 13. Okay, let's have a look at the next slide. So the next slide says if z1 is equal to 12 plus 16i and z2 is equal to minus 12 plus 5i, we've been asked to find out the modulus of z1, the modulus of z2, and then to add them up. So let's have a look at these. Okay, so modulus of z1, well, z1 is equal to 12 plus 16i. We're going to label it a and b, and then we're just going to put it through the formula. So modulus of z1 is equal to a squared, which is 12 squared, plus b squared, which is 16 squared, square rooted. And that's equal to 12 squared, which is 144, plus 16 squared. Get your calculators out and do this, guys, which is 256, square rooted. If you add them together, you get 144 plus 256, which is 400. And the square root of 400 is equal to 20. We know that one. Stick it in your calculator, that's what you're going to get. For Z2, so we know that Z2 here is equal to minus 12 plus 5i. Label them A, B. The modulus of Z2 is equal to A squared, which is minus 12 all squared, plus B squared, which is 5 squared, and you square root the answer. That means Z2 is equal to minus 12 squared, which is 144, plus 5 squared, which is 25, square rooted. Add them together, you get 169, square rooted, and the square root of 169 is equal to 13. Okay. The next question is Z1 plus Z2 and then modulise. So what we have to do first for this one is we have to add Z1 and Z2 and then take the modulus to see what happens then. So let's just go through that one. So we've got Z1 plus Z2. So let's work them out. We know Z1 is 12 plus 16i in the bracket, and we've got plus Z2, which is minus 12 plus 5i. And remember, in order to add two of these complex numbers together, we take the real parts, 12 and minus 12, add them together, and then we do exactly the same with the imaginary parts. So we have 16i plus 5i. So let's do that now. So 12 minus 12 is 0, so that's just 0 of the real values. And 16i plus 5i is 21i. So this is only an imaginary number because we have no real part. Okay, let's work out the modulus of Z1 plus Z2. So the modulus of Z1 plus Z2. Okay, and we know that Z1 plus Z2 is equal to this. So label them A and B again. So this is my A, this is my B. And we know that the modulus is equal to A squared, which is 0 squared, plus B, which is 21 squared, all square rooted. Work them out. Well, 0 squared is obviously just 0. 21 squared is equal to 441. So what we end up with is 441, the square root. And if we take the square root of 441, you'll find that the answer is 21. So what we had to do for this one is this acts like a bracket. We have to add them together first. We get a new answer. And then what we do then is we take the modulus of this new answer. The last part of this answer, it says, hence show that Z1 plus Z2 is less than the modulus of Z1 plus the modulus of Z2. So we've got all of the answers here, guys. So there, my Z1 plus Z2 modulus is this. My Z1 is this. And my Z2 is this, my modulus of the Z1 and Z2. So let's just see what happens. So we've got to show that Z1 plus Z2, the modulus, is less than the modulus of Z1 plus the modulus of Z2. So let's just put the values in. So the modulus of Z1 plus Z2 is equal to 21. Is less than the modulus of Z1. Well, the modulus of Z1 here is 20 because we worked that out earlier. That's 20 plus modulus of Z2, which is here, which is 13. And if we tied up the right hand side, we see that 21 is less than, and 20 plus 13 is 33. That's correct. So we have now shown that that there is true. Okay, the last one, what we have here is Z1 is equal to 8 minus I, Z2 is equal to 7 plus Ki, are two complex numbers. So what we have now is we're introducing a bit of algebra into this. Now, it isn't too difficult. We're going to do exactly what we did before, and then you'll see that we're just going to solve for a particular value. Okay, so Z1, let's just go through them again. Z1 is equal to 8 minus I. Label it A and B. Now remember, my B here is minus 1i, so just be aware that you don't put i's into these equations. So what we now have is the modulus of Z1 is equal to A squared, which is 8 squared, plus, and it's minus 1 in front of the I, got to square that, and we're going to take the square root of that answer. That's going to be equal to 64, and minus 1 all squared is 1, so what we end up with is 64 plus 1 square rooted, which is the square root of 65. And that's the first bit done. The next thing it asks us to do is to work out Z2. Okay, so exactly the same idea. So let's go to here. Z2 is equal to, and we have 7 plus Ki. All right, there's a little variable in there, the K, an unknown, but it doesn't matter. Let's label everything as we did before. That's A and that's B. Now we know that the modulus of Z2 is equal to A squared, and my A is 7, so that's 7 squared, plus B. Well, my B isn't a number, it's just a letter, it's K, so plus K squared, and we're going to square root it. We're then going to work out as much as we can, and you can see we can work out the 49 plus K squared, square rooted, and that's the best we can do. Okay, we can't take the square root here, guys, and say that this is 7 plus K. It isn't. You're not allowed to do that. Okay, so you just have to leave it in this form. For part 3, it says, if you have a look here, it says, if the modulus of Z1 is equal to the modulus of Z2, find 2 possible values for K. So that means that Z1, which we know is here, the modulus of Z1 is equal to root 65, and the modulus of Z2, is equal to the square root of 49 plus K squared. So what we need to do is just need to put them equal to each other. So root 65 is equal to root 49 plus K squared. Now, if I want to get rid of the square roots, which is what I'd like to, then what I need to do is I need to do the opposite, which is to square both sides. And if I square a square root, it disappears. So that means on the left-hand side, I'm going to end up with 65 is equal to, well, the square root's going to disappear. I end up with 49 plus K squared. I now just have something to solve. So I'm going to take the 49 across. If I minus 49 from both sides, minus 49 from here, I get 65 minus 49, which is equal to 16, and 16 is equal to K squared on the right hand side. Well, how do I get rid of this square? Well, I have to take the square root, and the square root of 16 will give me an answer of 4 and also minus 4. So when I take the square root here, I'm going to get 2 answers, and it's going to be plus and minus the square root of 16. So K is equal to plus or minus 4. I'm expecting 2 answers, guys, because it's a quadratic, i.e. there's a square, and most squares will give you 2 answers. So if I have K squared is equal to 16 here, it's always going to be plus or minus. Okay, boys, any issues, give me a shout, and good luck. And go on to the next exercise now.